Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 12 of GCP Zero to Hero series, and in this episode, we will deep dive into Google Cloud Artifact Registry. In the previous lectures, we learned about container images. We learned how to build and deploy container images on Google Cloud. In today's video, we will go a step ahead and understand how to store these container images and how to distribute these container images across different teams of an organization, which is more important than building and deploying container images. So for that, we will start with understanding what is an artifact registry, how is it different from Docker Hub, how to set up private container repositories on Google Cloud, and finally, how to define cleanup policies and access control for these repositories. Most of this video is going to be practical. Of course, initially I'll cover the theory part, but later I will show you all of these things practically using Google Cloud CLI. So make sure you watch this video till the end and practice the same concepts after watching the video. At any point of the video while practicing, if you run into issues, you don't have to worry. Within this same GitHub repository, if you head to the Day-12 folder, you will find a README file which has all the steps that I'm going to execute in this video. And these steps are also placed in the proper order so that you can just follow this document after watching this video and you can definitely complete the practice part. Perfect. Now, without wasting any time, let's head to the whiteboard and start with understanding what exactly is an artifact registry. So artifact registry is a resource on Google Cloud, just like how you have virtual machines as part of the compute engine. Similarly, you have artifact registry, which is useful for storing container images and non-container images. Now, why do we say container images and non-container images? Because earlier, Google Cloud used to have a resource called or a service called GCR, which is Google Container Registry. This resource was deprecated on March 2025. So right now, Google has only resource called as Artifact Registry, which is useful for both storing container images and non-container images. This is also very important from your interview point of view, because earlier companies used to use GCR. It was very, very popular, but Google Cloud has decided that for storing the container images and non-container images, it will provide support only for artifact registry. Now you might have a question, but Abhishek, why should I even store container images? Because in the last class we learned using Docker CLI, we learned how to build and how to run the containers or deploy the containers on the local host. So what is the point of storing these container images? It's very simple. The reason why you store container images, because end of the day, you don't want to run these container images only on your local machine. You might want to run it on the UAT environment, on the staging environment, on the production environment, or even you might want to share it with QA team so that they run some test cases and ensure everything is working fine. Apart from this, you might share the container images with your clients, you might share it with your devs. So for all of this, the container images should be stored at a centralized location. Now, one thing to note here, the other advantage of maintaining a centralized location within your organization, imagine you're working for an e-commerce company, and let's say one of the microservice that you deal as a DevOps engineer is a payments microservice. You need to understand over the years, multiple versions of this payment service will be created. It's not just a single version, but you might have V1 to V100 And within each version, you might also have subversions. So overall within your organization, for every microservice, you might have hundreds of versions. At the same time, you might also have hundreds of microservices as well. So technically, organization is dealing with thousands of images. So that is another advantage of maintaining a centralized location. Because if you have these thousands of images on a single person's machine, it will become a single point of contact and single point of failure as well. What if one of the version is deleted, but your devs need that version or your clients needs that version? So overall, for these reasons, we need a centralized location for storing the container images, and that is called as container registry. You can call it as CR. Now, Abhishek, but you said artifact registry is a combination of container registry and non-container registry. Yes. In Google Cloud, as I told you, because GCR is deprecated, now companies started using AR, which is artifact registry, where along with these container images, you can also store non-container images. Something like your application's jar file, your application's var file, or the binary of your application, which you usually have it in the dist folder of your local machine. You can also save multiple versions of these applications or multiple versions of these jar files within non-container images or non-container registry. In Google Cloud, both of them comes under AR. Very simple. If you head to your Google Cloud account and if you just search for artifact registry, right? When you try to create a repository within your artifact registry, you will see this option. Do you want to create a container image? The option is Docker. Or do you want to go with non-container images? Maven, that is jar file, var file, npm builds, Python builds. So you have an option to choose with. But Abhishek, what is this repositories? Okay, now I understood. Within Google Artifact Registry, I can create or I can store basic container images or even jar file, war file, or any artifact of my application. But what are these repositories within registries? Right? So I see here an option to create repository. What exactly is it? Very simple. As I told you here, within an organization, you don't have a single microservice. Right? So if you take AR, that is Google Cloud Artifact Registry, a cloud engineer would set up multiple repositories, just like for source code, how multiple Git repositories are created. In the same way, a DevOps engineer would create a repository in AR called as payments, a repository called shipments, a repository called UI, maybe a repository with name XYZ. So these can be names of microservices, and within each repository, as I told you, multiple versions of that microservice can be stored. One advantage that you get here is granular permissions as well. So you can say a particular team can have access to this repository, but not to this repository. Maybe if there is, secure images, you can say only a particular team should have access to this repo. Rest, no one else should have access to this repo. So technically, cloud engineers would create multiple repositories within AR, and within those repositories, cloud engineers would store the images. Cool. So what did we learn till now? We learned artifact registry is a combination of container registry and non-container registry. In the container registry, container images are stored. In the non-container registry, general artifacts are stored. It depends on the programming language where you can go and select the option. Now, a basic question that a lot of people have is, Abhishek, why can I not go with Docker Hub? Right? In the earliest classes, we build the images through Docker CLI. We run the images through Docker CLI. Now, why can't I store those images onto Docker Hub, which is a container registry? Right? Docker Hub allows me to store those images and I can distribute the images. In fact, it is true. And 99.9% of DevOps and cloud engineers, when they started learning containers, I'm sure they must have started using Docker Hub. Because with Docker Hub, you can create a free account, and on Docker Hub, you can create n number of public repositories. I'm not certainly sure about the limit at this point, but you can create multiple public repositories, and within each repository, you can save multiple versions of your public image. This is one of the reasons you might find a lot of open source projects still host their container images on Docker Hub. Just like Docker Hub, there is also Pay.io, right? Another popular open source option where again you'll find a lot of open source projects also store their container images onto Quay.io. So Abhishek, why can't companies go with such options? It's free of cost. They can technically store these images. Now the problem is that, of course, they are very, very good options. And today some companies also use it. But why majority of companies don't go with these options is because they want to have their images private. If we take the same example of e-commerce company, and if you're working as a cloud engineer with the e-commerce company, you don't want to have your images public. You definitely want to have your images private. And these offerings, they have certain conditions, not with Pay.io, but if you move to Docker Hub, there are certain conditions with private images, the number of images, the number of repositories, the number of or the rate limiting. There is certain criteria which makes the companies to look for alternatives. Now, the alternatives that companies have, there are two primary alternatives. Of course, for proof of concepts, for hobby projects, Docker Hub is great, Pay.io is great. But when you want to move from an enterprise option, or when you want to think from an enterprise point of view, there are two primary things. One is self-hosting, or second is managed offering. What is self-hosting? Self-hosting is you can take a container registry image, right, and you can spin a bunch of virtual machines. And on these virtual machines, you can create a cluster of your container registry. So basically, you can create something like your own Docker Hub or your own Pay.io, where you can ask your developers or you can ask your QA engineers to push the images and store the images onto this container registry. Now, the challenges here is that you have to maintain these virtual machines. You have to take care of OS patching. You have to take care of version patching. Whenever there is a new version of the container image, you have to make sure continuously it is patched. There is an advantage. It is completely in your hands. But the downside is that OS patching and version patching. To eliminate this, most of the companies today are looking for managed offerings. I mean, I'm talking about container registry. So what companies are looking for are managed container registries or artifact registries from the cloud providers. For example, ECR by Amazon, ACR by Azure, or GAR, where this is a shorthand for Google Artifact Registry. Usually people call it as AR. So AR from Google Artifact Registry. So the advantage that you get here is that number one, you don't have to manage, you don't have to do patching. Number two, these cloud providers offer high availability. Imagine you have someone in Australia within your team, you have someone in India, someone in North America. If you self-host and if you host these virtual machines, let's say in India, someone in Australia might experience latency. But when you go with these cloud providers, they offer high availability with just a click of button. Because of that, it becomes easy or there is no latency. You can eliminate latency. Number three, security. These public cloud offerings, the managed service offerings, they come with inbuilt container image scanning. So you don't have to go for external dependencies like Trivi, Claire, or you don't have to use anything else in your DevSecOps toolchain. And finally, the most important one is IAM. Cloud providers out of the box support identity and access management. We learned about authorization and authentication. Now, all that cloud engineers have to do is they have to set up or they have to just integrate IAM with the artifact registry in this case, and the job is done. They don't have to set up another identity database, or they don't have to set up another single sign-on. If they go with self-hosting, they might have to do it. But with the managed container registry offering, in our case AR, artifact registry, cloud providers can use existing IAM. They just have to update one policy. They might have created groups. So they can just say for the dev group, just add the read policy to AR. That's it. Everything is done. Or for the DevOps group, just grant write policy or write role to the Google Artifact repositories. That's it. It's done. So it becomes simple for cloud engineers when it comes to managed container registries, right? So overall, what did we learn? So we learned what is artifact registry, combination of container registry and non-container registry. We learned within Google Cloud, it is AR. Again, it is also called as artifact registry. The main reason for going with this is companies need a centralized location to store the container images. And what cloud engineers do? So they set up multiple repositories within artifact registry, maybe one for microservice. And within that, they store multiple versions of the microservice. How is it different from Docker Hub or Quay.io? They are actually great when it comes to your open source freelancing or when it comes to your uh, hobby projects. But when you want to move to an enterprise, you either have to go with self-hosting the container registry, or you have to go with managed container registry. With self-hosting, you have certain downsides, but with managed hosting, you get the power of cloud provider. So it comes with an integrated IAM, security, high availability, patching, and also policies that we are going to see. Now that we understood it, now let's move to the practicals. So what I'm trying to demonstrate in this video, as a cloud engineer, if you are asked to spin up a virtual machine, and within the virtual machine, or you have to associate virtual machine with a service account, so that when someone runs Docker CLI commands on this virtual machine, they will be able to push the container images to artifact registry. So now what we are going to learn in this demonstration, we will learn through gcloud CLI, right? How to connect to artifact registry, how to create a repository, let's say for the payments team, how to create a service account, how to associate service account with the virtual machine, so that when the cloud engineers run the Docker CLI command, maybe Docker push, that push will store the image onto the repository within the artifact registry. We will see all of this. So for this, step one, we will access gcloud or cloud shell. Step two, once we access the cloud shell, we will create a repository within the artifact registry. Step three, we will create a service account. We will grant write permissions to the service account. Step four, we will create virtual machine and associate it with the service account. Step five, we will connect to the virtual machine. Step six, once we are connected to the virtual machine, we will try to run the Docker CLI commands. So basically, we will build an image, then we will try to push the image. Of course, we will tag the image, and push the image to repository that we have created in the artifact registry. And of course, the eighth step is to verify everything is working fine. Once we are done with all of this, I'll also walk you through all the other available features as part of the artifact registry. Cool. So now let's head to our Google Cloud account. First of all, you need to have a project. You can create any project. If you have an existing one, you can also reuse the project. In my case, I have an existing one. This morning, I was just practicing few things with respect to container registry before I explain it to you or before I put concepts in place. So I'll be using the same project. Abhishek is the name. First thing, let's head to artifact registry. As I told you, you can just click few buttons and you can have your repository, but we will use Cloud Shell because experience with CLI is also important. We have done a lot of things through UI. In interviews, usually interviewers ask, what have you done with shell scripting? What have you done with CLI? Can you explain your day-to-day activities? You can explain these things. Now, whenever you sign in into Cloud Shell, most likely it becomes the same project. For example, right now the project ID is Abhishek.Veeramalla. It picked up the same thing, right? Right now my Cloud Shell is connected to the project. In case if it does not, what you have to do is you have to run this gcloud CLI command. So you can just run this gcloud config set project followed by the ID of the project. Right? So if you said something like ABC, then your gcloud will be configured to run instructions on the ABC project. In my case, it is already connected to the project, so I don't, or configured to the project, so I don't have to do anything. We'll export few environment variables. For this project, I need a project ID. I'll keep using it. So first, I'll export the project ID. Once again, I can get it from here. Even if you don't export these environment variables, it's fine, but you have to type the same things again and again. So instead, as a good practice, I'll export these environment variables. It's also a regular thing because on Google Cloud or any cloud platform, you keep using the region, you keep using the zone. So having them exported is nice. Okay, so region, I'll just export as Asia South 1. Zone, I'll go with 1A. And name of the repository. So these are the 4 environment variables I'm going to export. What would be the name of the repository? As I told you, it can be any microservice. We'll deal with, let's say, payments microservice. So I'll just call it as, let me just call it as e-commerce payments QE, okay, or dev. So this is the name of the repository. These are the common environment variables. I just exported them. Cool. Now, what is the first step? The first step is to enable the APIs that we are going to use. Because by default on Google Cloud, APIs are not enabled. We are going to use artifact registry. We are going to use compute. We are going to use IAM. So I'm going to export those APIs. Okay, sorry, enable those APIs. This command is idempotent. That means if these APIs are already enabled, it does not return an error. It just says successfully executed. Cool. Let's go with the first thing here. So we are done with gcloud. Second thing is to create a repository. Cool. So to create a repository, the command that we are going to use is this one here. Abhishek, how did you get these commands? Very honestly, I'm just copy pasting from here, but it took me a lot of time to gather these commands. I use the documentation. I don't go with ChatGPT for these things because the hallucination is high. You might get a wrong command from ChatGPT, and you end up wasting a lot of time. So just go to the Google Cloud official documentation. It takes time to frame these commands. I don't want to waste time here. So that's why I've already put them in the document, and I will be explaining these commands and using the commands at the same time. Okay. So cool. We have these environment variables. What is this command doing? Gcloud artifacts repository create. So it's creating an artifact repository. This would be the name of the repository. Already the variable that we exported. The repository format is Docker because we are creating container image registry or a repository, my bad. Location, we have exported the region, and this is the description. Nice. Let's see if it gets created. Waiting for the operation. Almost done. Repository is created. Okay, nice. Let's see. I'll refresh. We should have e-commerce payments dev. Very nice. So we have this repository. We don't have any images at this point as expected, but this step is done. So we have created a repository. Now let's go ahead and create the service account. Cool. So to create a service account, again, I will use the gcloud CLI. Gcloud IAM service accounts create. Abhishek, again, where did you get this command? Whether it is me or anyone else, even people who are working in Google, nobody can technically remember these commands. Everyone would reference document or they would take help from AI. You can also do any of these things. So gcloud IAM service account create. This is the name of the service account. If you observe carefully, I am not granting any permissions to the service account yet. This command is only creating the service account. I'll just change the name of this service account. Instead of AR pusher, I'll just call it as AR demo. Okay. Service account is created. Now let's grant permissions to the service account. gcloud artifacts repository, add IAM policy binding. That is, I'm trying to bind policy to this service account where this is the location, this is the name of the service account, and this is the policy or permissions that I'm granting. What is it? Artifact registry writer. So now this service account, whenever it is connected to the virtual machine, this will have permissions to write, that is to push a container image to the payments repository in artifact registry. Cool. So I'll just change this name to AR demo because that is the name. If you're copy pasting, you can use the same names. It's totally fine. Or you can change the name of the service account. It's up to you, whatever you want to do. Because I already have a service account with name AR pusher, I'm just changing it to AR demo. Okay. Now service account is created with the right permissions. Let's go to the next step and create a virtual machine. Cool. So gcloud compute instance create. What is the name of the instance? Again, I'll just change it from AR builder to, let's say, AR demo. Okay, I'll just call it as AR pay demo. These are the parameters. We are passing the zone. We are passing the instance type. If you want to make it even cheap, you can pass another parameter to make this instance provisioned with spot type of instances. But technically E2 Micro would charge you about $8 or even less than that. So it's fine. You might be doing this project for 30 minutes or maybe 1 hour. So it wouldn't cost you a lot. Maybe it would cost you in cents. Nice. Okay, what I told you, $8 is not per day, it's actually per month. So, technically, we will be just doing it for 1 hour, so we'll be charged in cents if you're going with a paid billing account. If you're using a free account, you will not be charged at all. Let's verify if the instance is created. I'll just search for instances here. VM instances, got it. Okay, it took a new tab and I have this AR pay demo. Let me close it here. AR pay demo. This is the virtual machine that is just created and it is in the running state. Cool. So now, rest part of the tutorial, you can either continue from the Cloud Shell. So if you want to continue from the Cloud Shell, all that you have to do is you need to connect to this virtual machine, the one that we created. So you have to connect using gcloud SSH connect. I explained you in some of the previous lectures as well. How do you connect to a virtual machine from the Cloud Shell? Or you can just close the Cloud Shell and rest of the tutorial. Because we have the instance created, uh, this is the instance. You can SSH from the browser and you can run the rest of the commands from the SSH browser itself. Because I showed you through Cloud Shell in one of the previous videos, I will use this SSH in browser. Okay, for this, we have to re-export the environment variables because we exported the environment variables on Cloud Shell. Let's do it one more time. Project ID. What's going to be the project? I just have to copy paste it one more time. This is the project ID. Okay, let me put it here. Nice. Then I'll export the region. Then I'll export the zone. If you are continuing from Cloud Shell, you don't have to do it again. Then I'll export the name of the repo. I believe the name of the repository is payments demo, but let me double check it. Refresh. Okay, so this is the name of the repository, e-commerce payments dev. So we'll have to copy paste the same thing. On the virtual machine, let me get it back. Okay, so this is the repository. Apart from this, these were the things that we exported last time. But apart from this, I'll also export the name of the container image. Okay, so I'll just call it as payments demo. I'll also export the tag. You don't have to export these things if you're not interested. You can just provide them dynamically, but we will do it 2 to 3 times. So I thought instead of always providing the name of the image as payments demo, I would just say $image, $tag. And finally, these are the important environment variables. You need to understand why I'm exporting the following 3 environment variables or following 2 environment variables. The first one is AR host. So in the previous lectures, whenever we created a Docker image, they are stored on the local host, right? But today we are going to push the Docker images to the artifact repo. Now, how would your Docker push command? When you run Docker push, how will it understand where exactly it has to push the image? Should it push to your local host? No, it has to push to the artifact registry. So you have to provide the information. What is the artifact registry host name? What is the name of the repository? Or what is the complete URL path? So that it can push the images to the repository that you have created in the artifact registry. And before pushing, it also needs the permissions. So step 1, Docker needs permissions. Step 2, permissions to what? Permissions to this repository. Step 2 is to push. Right? Cool. So I'm going to export few environment variables now. One is AR host. What is the location of the artifact registry? Region docker.pkg.dev. This is constant. It is always the same. So even for the projects that you are dealing with, you almost provide the same path. Finally, the image path. So this is the path that I'm going to use with Docker push command. AR host followed by the project ID, followed by the name of the repo, followed by the name of the image, right? So this is the name of the image. So I'm going to use the same image path. Cool. So we have all the environment variables set. We also have the virtual machine. Next step is to install Docker. First, update the repositories using sudo apt-get. Second, sudo apt-get install. Now let me ask you a question. While the packages are being installed, do you know why do we run apt-get update whenever we create a new virtual machine? Let me know in the comment section if you know the answer to it. Why do we keep running sudo apt update, sudo apt-get update? Depending upon the OS distribution, why do we update the packages? Because we just created the virtual machine. What is the point of updating these packages? Let me know if you know the answer. Okay, so it is almost done. Most of the packages are updated. Let's just wait for a minute. Okay, processing triggers. Then it has to, okay, it is also added the Docker group, setting up docker.io. Should be done in less than 30 seconds, if I'm right. Cool. Perfect. So now it's done. Next step, we will just grant the current user permissions to the Docker group so that we don't have to switch to the root user to run the Docker commands. So we just add the user to the Docker group. So we don't have to log out and log in back. Usually that is required to refresh the permissions of the group, but you can also run this command new group Docker. Now this will refresh the group permissions or it will automatically update the user permissions. Now you can just run the Docker CLI commands without switching to the root user. Cool. So we have Docker also installed. We have the virtual machine is also created. We have exported the environment variables. What is the next thing that we need to do? Now let's write a simple Docker file. Okay. So vim Docker file. So I'll write a very basic one. So I'll use Nginx base image and now I'll just write an index.html file and put that in user share Nginx HTML folder with hello from artifact registry message. Okay, so let's build this image. Docker build name of the image followed by, let's use a tag called local dot. So what happens? Now the image is built, but the image is built with local image tag. But to push the image, as I told you, Docker needs to know when we are running Docker push, it needs to know the path where this repository is located. So for that, we will tag with the AR host or we will tag with the image path variable that we have exported, right? Because what is the value of the, so when you see the value of this variable, you will understand where exactly image is being pushed. Going back to the browser. Okay, so if I just do echo dollar image underscore path, or what exactly was the name of the environment variable? Let me go back and check the one that we created. Okay, img path, img path. So we are basically interested in pushing it to Asia South 1 docker.pkg.dev, followed by Abhishek project, followed by e-commerce payments dev repo, and this is the name of the image. So what we need to do is Docker images. This is the image ID. So we have to tag it Docker tag. This is the image ID with, what are we going to tag it with? We are going to tag it with image path. So I will just say image path colon tag. Now, if you see Docker images, you will find Asia South 1 docker.pkg.dev. Abhishek, this is the project, this is a repository, this is the image, and this is the path. Now I can simply say Docker push followed by image path and the tag. Cool. So, okay, it says authenticated requests do not have permissions. So there is some permission issue. Let me just see what might have happened. Oh, we just missed a small thing. So as I told you, you have to grant or you have to let Docker know where is the AR host. So it has to authenticate with the AR host, right? I mentioned that point here when I explained this thing. So you have to do it in two steps. Step one is to grant permissions. Step two is to push. Unfortunately, I missed step one, but that's okay. Yes. Cool. Let's try it one more time. Docker push. And let's see what happens this time. Again, it's the same. What does it say? Denied. Okay, so it is done, but how is it done? So I did a basic or a very simple mistake. So when I looked at the virtual machine, so I'll just quickly show you. So this is how I troubleshooted the issue. When I looked at the instances, so this was the instance, and to this instance, the service account that was attached was completely wrong. So these are the instances, right? So the instance that we're dealing with was ARP demo. We were actually supposed to attach the service account. So if I see the service account, it is AR pusher. But if you remember, we created a service account with name AR demo, right? So we used the wrong service account. Because of that, the Docker push failed because this service account, I had it earlier. This did not have permissions to the artifact repository. So what I had to do, I had to go back to service accounts. I had to go back to manage service account. So you can see that I recently clicked on it. So I went to it. I enabled permissions, uh, right? I enabled permission to push to the artifact registry. That's how now it is successful. Anyways, you will not run into this issue because I already had some service accounts. I had to change the commands. Because of that, it failed, which is good. Now we understand steps to troubleshoot as well. Okay, going back. Now, if we look at the artifact repositories, right? So we should see the image payments demo. So the image is pushed. Awesome. So this is the image and this is the tag. V1 is the tag. If you remember, this is what we pushed to the payments demo repository. Perfect. So we learned how to use the artifact registry, how to create a repository, how to push the image. Now, what are some interesting features of these repositories? Right? Instead of going with Docker Hub, we decided to go with it. What are some cool features? Number one, as I told you, you can choose between container registry and non-container registry. Apart from that, you can go with high available setup, multi-region setup. If you have some teammates in Australia, someone in India, someone in Europe, this will help a lot because they will not see the latency. Then you can also encrypt. So you can make it even more secure by using Google managed encryption keys or cloud KMS keys. If you're going with the KMS keys, you have to manage those keys. You have to rotate those keys in timely basis. So better if you're going with encryption, go with Google managed encryption key. Or yeah, it's up to you if you want to use your own keys. Then you can also define policies like the cleanup policy. For example, it's been few years you have been using this artifact registry or few months and you have tons of images. Absolutely, there will be some images which are pushed during CI/CD process or which are pushed for some test purposes. So you can define the cleanup policy where you can say delete artifacts. What kind of artifacts? Artifacts that are probably untagged, right? You can just say untagged, and you can say if you find any untagged images or container resources, you can just delete them. So you can also define such cleanup policies. Of course, you can enable and disable IAM, something like we did in this video. We created a service account, and to this service account, we enabled IAM permissions. You can also do it with container artifact registry. Sorry, Google Cloud Artifact Registry. So I hope you found this video insightful. Let me know what do you think about this video. Now, do you have good hands-on with Google Cloud CLI? And did you understand the concept of artifact registry? If you find it interesting, just leave a comment. It motivates me to do more such videos. Thank you for watching the video. See you all in the next one. And don't forget to delete the resources. I have the cleanup steps as well within the document. So go ahead and clean up the resources. Take care, everyone. Bye-bye.